Hello friends, I keep on pushing L'Hôpital's examples. There are so many. Maybe I should have done a separate playlist, but well, there are maybe 2 or 3 more videos coming up, so I hope you guys learn something from them. So let's see the new example, limit x towards infinity, and we have a challenge, logarithm of x divided by, well, it actually doesn't matter which, let's take fourth power, I think it is, or 8 or 17th, whatever, it doesn't matter. It's about root against ln. So both are running towards infinity. What would be the limit if we produce by the rule of L'Hopital derivatives? Well, we're going to get 1 divided by x in the numerator, and here we got x to the power of a quarter, so it's going to be a quarter x to the power of minus 3/4. Can we simplify it? Sure, it's 4 limit x towards infinity. We got 1 divided by x, or let me write it this way, x to the power of minus 1 divided by x to the power of minus 3/4. So what's happening here? We are subtracting minus 1 minus minus, so the result is x to the power of minus a quarter, or 1 divided by the fourth root of x. So this is what we get. And can we compute this value? Sure we can. This is going to be 0, right? Because the denominator is exploding and the numerator remains still. So the result is 0, which means whatever root we take, the speed at which it develops is greater than the pace of ln. That's it. All right, let's move on to the next example. I have a limit x towards 0, pi divided by x over cotangent of pi halves x. Okay, do we have a problem? Yes, we have, because if we put, so cotangent is cosine divided by sine. Let me remind you, cotangent of x, it's a cosine of x divided by sine of x. And if we produce derivative, I think I've done it, it's quotient rule, so it's derivative of the cosine minus minus, so it's minus sine squared of x minus then cosine squared of x divided by the sine squared of x. You can take minus out, and then you're gonna get 1. So it's just minus 1 divided by the sine squared of x. One of the possibilities to write the derivative in this case. And since we get a sine in the denominator, of course we have a problem if x is approaching 0. Pi divided by x has a problem at 0 anyway, so we can take pi out and let's kick the derivatives, right? So 1 divided by x is minus 1 divided by x squared. And what about the cotangent? Well, as you can see, it's minus 1 divided by the sine squared of pi divided by 2x. And now we also need the inner derivative, which is pi divided by 2. So let's simplify it. If we can divide pi's. 2 is coming up, so we can take 2 out. Minus is gone as well. And sine is coming up. So I hope you can follow. This is limit x towards 0. We got sine squared of pi divided by 2x divided over x squared. Well, what's happening here? If you remember, sine itself sine of x divided by x is giving us 1. But what is happening? So let's rewrite it to limit x towards 0 of sine pi divided by 2x times 1 more sine pi divided by 2x. And now we have x and x. You see that? So I kind of would like to use sine of x divided by x, but I don't have it. Well, you see, let's artificially put pi divided by 2 twice here in the denominator. So that means I need to put 2 divided by pi squared up here. So basically 4 divided by pi squared, we have an extra 2, so it's 8. What would that mean? That would mean this one is 1 and this one is 1 as well. Isn't it nice? Yes, it is. Because the result would be 8 divided by pi squared. I like that. Hope you too. Okay, and the last for tonight would be a limit x towards 0. We have ln of sine of mx divided by ln of sine of just x, and m is some whatever constant. Are we in the trouble? If sine is if x is 0, we get 0 from the sine, so sine is 0 as well, and ln is approaching minus infinity in both cases, so minus infinity divided by minus infinity. Both are differentiable, so L'Hopital is coming. This is 1 divided by the sine of mx times the cosine of mx times m in the numerator. This is 1 divided by the sine of x times cosine of x. That's it. Can I simplify something? Well, I should be able to take m out for sure. So we're getting to m times limit x tilde towards 0. So what do we have? We have cosine of mx times sine of x, right? Divided over sine of mx times cosine of x. All right. Does it make sense? Think it's fine. If I would put for x 0 now, I'm still having some troubles. Next, so with no cosine, but for sure with sine. So how can I rearrange it? I think we've done it yesterday. We've done it with the tangent. Sorry, yeah, that's a different one. Well, let me remind you maybe. What will be this value? Or I don't want to do L'Hopital for the second time. That's for sure. So if I have if the limits exist, I would like to rearrange it. Look at this. I have cosine mx divided by cosine x, so those two exist, and then limit x towards 0. The same stuff with the sine, so sine x divided over sine of mx. Well, let's see what is happening if we have limit x towards 0 of sine of 5x divided over, or what do we have here? We have a bigger, okay, so let's take only sine of x here, 1x divided over sine of 5x. So what will happen here? I can write it as a limit x towards 0 sine of x, and the limit of 5x and sine of 5x, it's kind of the same. So you see what's happening. I'm putting 5 out, and I'm getting sine of x divided over x, which is just a fifth. Is it the same for the cosine? I mean, what is the cosine of limit x towards 0? I think we have different here. Cosine of 2x divided by the cosine of x here. Am I in trouble at all? I mean, if I'm putting for x 0, I'm just having 1 divided by 1, which is 1. So no trouble at all. I don't need L'Hopital or whatever. So what does it mean? That means this one is giving us 1. This one is giving us 1 divided by m, which we can cancel with this m, and the total result would be 1. Once again, why were I allowed to why was I allowed to take the limits apart? Well, the thing is, I have a product of two factors, and if the limit of each factor does exist, I can split it into two parts. This is the so-called product rule of the limits, which I proved on my channel. I'll link it here again, and that would have been the third example in this L'Hopital's part number 4. Thanks for watching, guys. See you in the next video. Bye bye.